Now turns to Part 2.
Part 2.
You'll hear a lecturer talking to students about a printing process. First, you have some time to look at questions 11 to 15. Now, listen carefully and answer questions 11 to 15.
As I've made clear in earlier lectures, many different solutions have been proposed to the basic technological problem of getting meaningful marks onto paper. In other words, several different forms of printing have developed over the years, many of which are still in use today for different purposes. This week, I'd like to discuss the rotogravure process. This is one of the most widely used printing processes, and after describing how the process works, I'll be describing some of its industrial uses and the advantages and disadvantages of this form of printing. As the name implies, rotogravure is a form of printing in which large cylindrical pieces of metal rotate, while the paper to be printed passes between them. The paper is held in place against the printing surface by the impression roller. The weight of this roller is one of the factors that affect how much ink is actually transferred to the paper. Remember that this roller does not directly transfer ink onto the paper. The side in contact with the impression roller remains blank, and it's the other side of the paper which is actually the printed side. The impression roller presses the paper against the ink-bearing roller, generally known as the gravure cylinder. This roller is etched or engraved using either a laser or a diamond-tipped etching machine. This creates a large number of tiny holes in the surface of the roller which hold the ink. The depth and size of these holes determines how much ink is picked up from the ink fountain, which the whole printing assembly rests in. How much ink is picked up, in turn, determines the density of the image produced. As it rotates, the lower roller picks up more ink on its surface than is required, and this needs to be removed before contact with the paper. A flat edge, called the doctor blade, scrapes against the surface and removes all ink which is not in one of the holes on the surface of the lower roller. This should lead to a clean image.
Before you hear the rest of the talk, you have some time to look at questions 16 to 20. Now listen and answer questions 16 to 20.
Now that we understand a little of the mechanics of rotogravure printing, I'd like to look at it in the wider context of the printing industry and discuss the main uses. One of the main advantages of the rotogravure process is that the amount of ink which can be transferred to the paper is high compared to other printing methods. This means that a broad density range can be produced. In other words, with rotogravure, it's possible to produce many different light and dark shades, making it particularly suitable for reproducing photographs and fine art. For shorter print runs, some other processes may give a finer image, but rotogravure is ideal for jobs that involve printing, for example, 1 million magazines. One common place where you'll see printed matter that has been produced by rotogravure is in the advertising material that is often inserted into Sunday newspapers. Of course, it's not just paper that can be printed by rotogravure. It's a very flexible process, since the rollers used can be made to any size required. Whether it's consumer packaging or large rolls of floor covering that need to be printed, rotogravure is a relatively cheap, quick method that is used in a variety of industries. This isn't to say that rotogravure is without its disadvantages. Probably the main drawback is the fact that, with large areas of colour, the dots are visible, even without using any kind of magnifying aid. Now, does anyone have any questions about the rotogravure process?
That is the end of part 2.
You now have half a minute to check your answers.
Hi, this is IELTS Bob. I would very much appreciate it if you could like, subscribe and share this video, as this will enable me to help more IELTS students reach their IELTS goals. Very much appreciated. Thank you.